Hello everyone, this is a video lecture for Business Calculus 1325, section 12.3. We're going to be doing differential equations, growth, and decay. So differential equations are basically just derivatives. So we're just going to be doing derivatives, but we're going to be moving the variables around a little bit. Honestly, differential equations is a whole other class, and you're supposed to tackle it in one section. It's just not going to happen. But we will touch on it, and that's going to be fine. So I am going to skip one of the problems on the homework. Let me just go ahead and tell you ahead of time. So 12.341, I'm skipping that to the end. It's like one of the last problems I'm going to do. And so as I go through the homework, it might seem like, oh, he's not going to do it, but I will do that one for sure. I just want time and place, you know what I mean? Because I don't like how it's earlier on. So moving on, that we'll see this for sure. I'm just skipping it temporarily. Okay, so there's really not much else to say. There's not really like a lecture so much as just showing you kind of a few examples and going through it. So we got dy dx is equal to 8x, and they basically are saying solve for y. So yeah, this is super easy. I'm just going to move the dx to the other side so that it looks kind of like this. Now, what's happening here is that I got a separation of variables, essentially. I got my y's, dy's, and all that stuff on one side, and my x's on the other side. And that's what we're wanting. We're going to separate our variables so that we can then integrate both sides. And so it simply you just integrate both sides like this. Well, the integral of basically 1 dy is going to be a y, and that's just what it is. It's always going to be something pretty simple, like at least for now. And then this guy is the actual integral that you're going to be doing. So we keep the 8 in the front, and then we say add 1 to the power and divide by the new power, and then put a plus c on it. Of course, 8 and 2 will cancel, so that we get a 4x squared plus c, and that's it. Now, I believe that they want the y equals included on the homework, so just watch out for that. So there you go. That wasn't too bad, right? That's a differential equation. Woohoo! The big thing here is that it's kind of in a weird position. It's a weird setup, and we just manipulate and change it to be able to get what we want. Okay, so here's the new one. That's e to the 0.02x. And it's a solve. Same as the last one. Very simple. So I'm going to multiply that to the other side. Dy. And then I got my e. And I got a dx. Integrate both sides. So y is equal to. And really, I want to just give you the answer, if that's okay. It looks like this. Okay. So, and that's it. You're done. What did I do here? Well, just like I had the powers and I divide by the new, or I add 1 to the power, divide by new power, it's kind of the same with the exponentials. Instead of bringing the number down, I'm going to divide by it so it's on the bottom. It just keeps it really easy. You don't have to do u sub on all these, right? Like, oh, u is equal to this thing, and then du is equal to this thing here. Oops, dx, sorry. And then now I have to divide that to the other side, and this takes forever, man. You don't have to do all this. See, look, I'm dividing it. There it is. So it's way easier just to kind of understand the patterns here about how that works. So there's a rule for exponentials essentially. Cool. Okay, let's keep cruising. So next one. I got 12.315. So ds dt is equal to 16t squared plus the 9t minus the 2. And they give us an initial condition of s is equal to 118. Oof. We'll keep it. And t is equal to 0. So, I mean, this is not any different than any of the other problems we've already done. Move it to the other side. And then I can now integrate both sides. See, what's happening is that this right here is the Leibniz notation. I think that's how you spell his name. Leibniz notation, which makes it super easy to be able to do all this calculus movement. If you were left with S prime equals something or other, that would be the Newtonian way. It's just not as cool. We use both. It depends on the situation. But here in differential equations, at least right now, without having to get all like crazy, the Leibniz methods of writing these derivatives out make it a lot easier. Okay, let's keep cruising. So I of course integrate. So add 1 to the power, divide by the new power, again, and again, and again, plus C, and you're done. Do they want the S? I don't have it boxed in, so I think this is good enough for them. Okay, cool. If you can't tell, like I'm very nasally today, and yeah, it's like crazy allergies or something right now. So I'm sorry for that. Might have to pause here in a minute just to blow my nose. So if it seems like I'm skipping or jumping or cutting something, then yeah, it's because of that. Okay. So this is really no different than any of the other problems. I think they're just wanting us to practice a lot, and that's fine. So I'm going to move it to the other side, just like every other time I've done it. And then I'm going to integrate both sides. And so I get y equals, and then boom. All right, so this one's a big one. This is a big doozy. We've got to figure out what to do here. Can I erase those? And I normally could, right? Erase. 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 All right, it's not erasing, whatever. So I'm wanting to integrate this big thing. And this is definitely a U sub for sure. I mean, I as a teacher could probably just see it and I could do it, but that's not the point here. I want to show you what's going on. So U is equal to the negative x to the 8th. du is a negative 8x to the 7th dx. Again, all I did was bring that down to the front. And this is not satisfactory for me. I'm going to move it over so that dx is equal to du divided by all this stuff, which you'll see is going to cancel here in just a second. So now I've got integral of the negative 8x7 e to the u du over the negative 8x to the 7. So all those guys cancel. So that's kind of nice. So integral e to the u du is just going to be e to the u plus c. And I already have my u. It's a negative x to the 8th. And there you go. Let me just look ahead. They want a little bit more done to it. Oh yeah, right here, the initial condition. Okay, so like this is cool, we like it, but we need to do a little bit more. So I'm going to plug in a 0 and I should get 2. So if I plug in a 0, I should get a 2. Anything to the 0 power is a 1. Minus 1 on both sides. So C is equal to 1. And so my final answer would then be y equals e to the negative 8x and then plus 1 essentially. And again, I only have this portion blocked off, so I guess that's good enough. There you go. So I have some mentions right here. And I don't think I'm going to write down what I have, but I'm going to talk about it, of course. It's multiple choice with double prime, y double prime. So you'll see this sometimes. That's y double prime. It's just second derivative. I think we've probably seen that at some point, but well, there you go. Y double prime. There's multiple choice. I don't really do multiple choice here on the videos because it's multiple choice. You know, you can figure that out eventually. And then finally, there's these things called slope fields. Slope fields, and I'm just going to give you like a quick demo of what one could look like. Something kind of like this. And this is a pretty bad one, by the way. But there's like a curve that follows those little lines. Those are all like little mini tangent lines, little mini slopes. And so if you follow the curve, see how it's like going down and it comes back up. Like right here is a lot of flat lines, basically, because it's flat right there. There you go. So yeah, it shows little tangents, little slopes, and you just follow the lines. So as just another example, if I had something that looked kind of like this, give me one more second. There you go. Now I know it's not perfect, but like you could see there's like a flow with it. So see how this one's going up? Well, that's technically going down left to right. Flat, going up, flat, going down. So just follow the curves. That's what's going on there. Okay, I gotta pause. All right, I'm back. I wonder sometimes, like, about actors and stuff. Do they ever, like, get sick, you know? And then, like, do they ever sound like they're sick? No. I don't know. Just kind of weird. Moving on. Y equals. I got a cap M, 1 plus CE to the negative KM, and then a little t. And they say, find T when Y is equal to M over 2. Okay, now hold on for a second, guys. This is all like letters. Let's just say you get it wrong 3 times. You're going to see the answer, right? But I wanted to do this one because it's a classic problem. This is logistic growth. And it's really cool. Now, specifically with all these letters, you know, that's fine and all. But what's really going on is that it looks kind of like this as a graph. So logistic growth kind of looks like exponential growth for a little bit, but then it starts to slow down and then it caps off. This top is at M. So whatever the M numerator is, that's the cap. So if it's like 1,000, it's 1,000. If it's 100, it's 100. This is really useful, like with like population growth, because there's only so many people that can like fit like in a country, I guess, because it's like just so much dirt, you know, to stand on. There's some models in like our other algebra classes about world population, and they are saying that it's about like 12.5 billion. And so that would be the max you would have right up here. It would be 12.5 billion or whatever that is. So it's actually a pretty handy thing. It's pretty cool. Real world situations. Another one is that you can only have so much, according to like how much, like let's say your business people, let's say how much product, you know, or how much your customer base is. So like you have a customer base of, you know, some amount. It's not going to be 12 billion, but it's going to be some amount. And you can like, the word gets out and you're like growing, and then like everybody already knows you, and there you go. It's like, I know everyone eats McDonald's, but let's just say like kids eat McDonald's only. So there's only just so many kids that are going to be eating McDonald's. It's just because like there's other things going on. I don't know. Anyways, this is a pretty cool problem. I'm sorry. I'm just talking. I'm rambling. Y equals M over 2. So like, yeah, mostly whenever I have just letters and stuff, I skip these kind of problems, but it's just such a cool problem, you know? Notice that they both have M in the top. I think we're going to cancel that out here in just a moment. Oh yeah. On my paper, I just like skip right to it. One idea is that you're looking at them kind of the same. Like, what if I took this 2 and multiplied it, took this thing and multiplied it, and canceled my M's out? So essentially, whatever was in the denominators is now in the numerators. Without getting like too weird, but like if you have something over 2 and the same something over something else, those got to be equal. They got to be the same. So I minus 1 on both sides, and I'm going to divide by this C. I'm sorry for the audio quality today with my my allergies, but I got to do these videos, man. It's been a while if you noticed, like time-wise, what's going on there. So I have E by itself. How do I cancel that? Is going to be an ln on both sides. So natural log with the E, and they're going to cancel. One thing about this class is sometimes I wonder, like, how much of this stuff you remember from, like, other classes. Kind of like this LNE thing. Are you supposed to already know that? Did you see that already? It's like one of those more basic things that I'm assuming you know, but I don't really know if you know. I don't think we touch on that very often here, at least. So yeah, E and ln cancel. Yeah, there you go. And that's an ln. ln as in like log natural base. Okay, I don't know if we talk about this enough, but really, I have people saying, "Oh, that's IN," because it kind of looks like an I. If you just do like this, it looks like a capital I. It's not. It's L. So it's L. Okay, cool. Now you know. So get T by itself. I'm going to divide by both of these things and that negative. And it looks funky. And we could definitely do a lot more to simplify this guy. Let me see what I did. Oh, yeah, I did more. So notice that this is 1 over C. So you could also say that C to the negative 1. And then that negative 1 can come out to the front. I mean, these are like these rules that I'm assuming you know. But, I mean, you're not like you're a business person, you know? It's a little different for you. So, yeah, there you go. That's what you do. Yay. Again, it's all letters, so you get the answer, but I just thought it was really cool. So, 12,381. Okay, so is this the one? This is getting closer to like, yeah, this is actually getting to some real stuff now, okay? So I got dpdx is proportional to p. They also say p at 0 is a 100, and that p at 8 is equal to 67.48. Okay, let's time out for a second here. I think that it's like x is units, p is price, something like that. In the end, that's not going to be a big important issue here. You're really just wanting to see this. This thing here is proportional to that. When it says this word here, it's a very key word. It's saying that you're multiplying by k. And I use capital K. It could be a little k, whatever, but k. So let's talk about this. We got dp dx is equal to k times p. That's what this statement says, is right here, okay? So, like, they're going to be bringing this up later. This is the important part. I don't think that this is necessarily differential equations, but it is something important. Okay, so what do we do at this point? Well, I'm going to multiply this over here, and I'm going to stop and show you that we're actually not done. That's normally what we do. You go back up to all the other problems, that's what you do. But not here. We need to do a little bit more work. So I need to divide by p on both sides. And the reason why is because I'm wanting to separate my variables. I'm wanting all of my p's on one side and my x's on the other. Now, I want to keep k with this guy because he's in the numerator. It makes it easy. It's just tradition to keep the k on this side. But your p's have got to definitely be together on one side. Okay? Now you integrate both sides. And this is where it gets a little bit weird. So I got integral of 1 over p dp. And then the k comes out to the front, integral dx. Well, this was super easy. That's just an x plus c. Now, what about this guy? Surely we've seen this before. Again, it's been a while. I don't know if y'all remember exactly either, but integral with this guy is absolute value. So it's a natural logarithm with absolute value in there. The absolute value is important, not right now, but it is important later, like for other problems. So anyways, ln, it's a logarithm. Okay, cool. So how do I get rid of the logarithm? Well, just like I had ln and e cancel, now I got an ln, so e is going to cancel with that. I'm going to e both sides essentially. And so then I got this big thing here, all in the power, and there you go. That is definitely not good enough. We need to keep going because it doesn't look right. Let me give you what is going on. This is really what's going on. Now, they look completely different to you, and I get that. And maybe I'm a traditionalist, I don't know. But this is the way we should have it for sure. And going forward, you're going to see how there's a strength to having it like that. So what am I going to do here? How do I get from here to here? Well, essentially what's going on is that I'm splitting this up with that plus sign up here. It looks kind of like this, and I'm multiplying those two bases. Think about this for a second. I'm multiplying the bases, therefore I add the powers. You don't normally go this way. You often go this way. So, and again, I'm assuming you remember all these things, right? We'll see how this e to the c, it's e to a constant is itself equal to a constant, okay? Now, this is where things break down just a tiny, tiny bit. If I was to be proper, this is a C1, C1, C1. This now is a C2, C2. Essentially, it's a different constant, yet still a constant. So I know that's going to be a little tricky, but like we don't need to have all these ones and twos. This is way too complicated, right? That's too much. Just know that e to the c, it can be a c. It kind of mushes together. I know that's weird, I know. But like here, let me demonstrate. Since I got this guy, right? Let's say I got like, I don't know, 2. That's pretty easy. And then I got e to the 2. So like 2, this is not equal to 2. I know they're different, right? They're different. But it's still a number. It's just a number. And I don't know what that number is anyway, so I just put a C anyways. It's just me being kind of lazy, but kind of proper. I'm showing you these things because they're important. Not just for this one problem, but as we keep going as well. Plus, I'm like, I'm not a business guy, I'm a mathematician, I guess, so I have to like, give you more mathy stuff anyways. So I'm rewriting what they had given us earlier. So the reason why I want it in this form is because this 100 is going to basically just go right there. If you plug in a 0, you get e to the 0 is a 1, and so basically whenever you have something with a 0, you could just put that number right here and you're done. And that's why we have it in this form. It's a lot easier. We like this form. It's really cool. So you can just do that. This one's a little bit more. So I'm saying it's equal to the stuff here. And I don't know what my k is, but I could plug everything else in. And I need to solve for k. So first off, divide by the 100. How do I get rid of the e is with an ln, once again. I should probably go find that thing. Here, I got a calculator right here. Let's do it. Zero. Nope, it's not a 0. It's a 3. 39333. Oh my gosh. Is equal to 8k. Divide by the 8 on both sides. Did you see how I did that? I did A and S. Divide by 8. So this is my rate. Sweet. That's great. Still not what they're asking for. They're wanting the final answer. So P in terms of X was equal to CEKT. And so we got it 100. E to this negative number. X. There you go. Oh, T? It's not T, it's X. X. Okay, that's good enough. Sorry about that. There you go. Cool, we did it. Yay! After that, they're going to say, hey, use this new formula. Find P of 20. So you just plug a 20 in there. And that's pretty easy. Ah, Desmos, why do you do that to me? Very annoying. It assumes that, like, I'm not knowing what I'm doing, and I have to go and clarify. No, I actually know what I'm doing here, Desmos. There we go. Okay, so now it's time to go back to the one that I skipped, if you were following along. So we need to go back to this one. But before that, I need to pause again. I don't know how many of these videos I'm going to get done today. I don't know how many of these videos you want me to do today. Given my nasal sounds and stuff like that. Okay, anyways. So this is the one I skipped. It's very similar to the last problem. I think it's a little bit easier, but it's still really cool. So this is that whole like K proportional thing. We just did it, but now we have a number for K, so that's pretty cool. All right, so here we go. Multiply and divide that to the other side. dy over y is equal to this negative 0.3 dx. And when I integrate both sides, I get ln of y is equal to negative 0.3x d plus c. I both sides. And just like the last problem, there you go. Like, if you know what you're doing, it really goes way faster. That's why I recommend practicing this stuff. And that's why I tell you these concepts. Like, hey, let's go through the long way, but it's not too bad. And then they give you one with a 0. I mean, right here, it's just so easy now. So your answer, you just put a 60 here, and then you're done. That's the power of this stuff, man. That if you know what you're doing, apparently it's only this one. If you know what you're doing, you could just kind of slide it in there, and it's not a big deal. So if I would have done this one in order, this one would have taken a long time, just like the last problem. But because I knew what to do, it's so much faster, so much easier. You don't have to spend all that time blah, 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 okay? I have one last problem. 12,392. All right, that's a 102. Sorry, it doesn't look very good. Okay, it says, what is the rate of improvement at 9 hours? So rate of improvement at 9 hours. And then I think they want it also at 43 hours. They want n prime. So we're going to say n prime derivative of this guy. Like, I don't know why. It's not that big of a deal. So we keep the 102 in the front. The 1 goes to a 0. This thing's coming down. 2 negatives make a positive. And you leave the power alone. And then you plug in a 9. You don't need that 0, obviously. But, yeah. Here we go. So 102 times the... Here, look, I'll even put the 0 in there. It does not matter. Awesome. So there you go. So when we plug in a 9, we get 2.3359. And then they're wanting a 43, I believe. So we just go back and plug in a 43. I don't even know why this is in this section, honestly. We were doing differential equations, and now we just did a simple derivative, so whatever. It happens, I guess. There you go. All right, that was it for that section. Woohoo! Thank you very much. Have a great day.